Hey everybody, it's Jane from Norman S. Wright. Last week I answered the question, what are chilled beams? And since chilled beams, underfloor air distribution, and displacement ventilation are often grouped together in a category of green or sustainable systems, I thought I would talk about them back to back. So this week, let's answer the question, what is underfloor air distribution? Let's get started.
Underfloor air systems, also known as UFAD systems, use the underfloor area of a raised floor system as part of the HVAC system. Raised floor systems were originally primarily just used to run cable under computer rooms and data centers, and any air that was supplied was used to cool the computers, not for personal comfort. So I'll discuss data center cooling in our new video series, NSW Pep Talks. So I'll link to those below, but right now we're going to talk about comfort air. Typical raised floor heights for UFAD systems are between 12 and 24 inches, with 18 being the most common. If you go lower, it's hard to put in the equipment under the floor and still have room for the air to move around. If you go higher, you can increase your floor-to-floor height. Let's move this up and make some room. In a UFAD system, you pressurize the plenum space between the raised floor and the slab. Diffusers designed for UFAD systems are used to supply air to the space above. The floor is pressurized to under 0.1 inches usually, and this pressure is maintained by dampers controlled by pressure sensors throughout the floor. You can only go so far across the slab with your supply air before it starts to warm up. Usually you want more than 50 feet or maybe even closer to 30 feet to be your furthest diffuser. So if the air came in here, this would be 30 to 50 feet away. Let me slide this up again and make some more room. You might also see air highways in the plenum. Air highways are basically ductwork run in the plenum that have dampers to control the airflow into the plenum. So it might look something like this, where you have different dampers controlling the airflow so that from any exit point in the air highway, you're 30 to 50 feet away from the furthest diffuser. So let's move this again. Air leakage from the plenum is an important consideration. On the top side of the plenum, the carpet tiles do help seal the plenum some, and any leakage will go into the occupied space, so it's not as big as an issue as it is with overhead duct leakage, where the air would go into the ceiling plenum and be wasted. A bigger concern is sealing any wall penetrations in the plenum space so that the supply air doesn't leak into the space between the walls, which would be a waste of energy. Let's move this over again. One benefit to a UFAD system is that you only have to cool the occupied zone. In a traditional overhead system, the diffusers are on the ceiling, and the air from the diffusers has to travel across the room and down into the occupied space. You have 55-degree supply air that mixes with the room as it rolls the room, so by the time the 55-degree supply air travels the room, it should be about 75 degrees and 50 feet per minute for comfort in the occupied zone. But you've cooled the entire space to about 75 degrees. In an underfloor system, the supply air is supplied at the floor right into the occupied zone, so you don't have to cool all the way to the ceiling. You only cool the space where the occupants are working in the occupied zone. In a UFAD system, you want to create a stratified layer of warmer air at the top of the space. Because you're supplying air directly into the occupied zone, you can use warmer supply air temperatures. So at the diffuser, you usually see between 60 and 65 degrees supply air. Let's move this over again. Underfloor systems use diffusers designed to provide high mixing as close to the diffuser face as possible so that you can get to about 75 degrees and 50 feet per minute close to the diffuser. You can also see displacement diffusers, but I'll cover that when I talk about displacement ventilation. So the diffuser would look something like this. They're typically round and they sit into the floor tile. They have some sort of pattern in the face that creates a high induction swirl to mix in the room air. They would be about 50 to 100 CFM per diffuser, and then the throw, which would be up from the diffuser face, is 4 to 5 feet so that it doesn't break the stratified layer in the room. Let's move this over again. If we draw a simple office area, the diffusers would be placed about every 10 feet across the space. The area around the diffuser should not be occupied. It's called the clear zone. A typical clear zone would be about a 2-foot diameter around the center of the diffuser. Outside this circle would be the approximate 75-degree and 40 to 50 feet per minute to meet ASHRAE comfort requirements. The diffusers can be simple manually adjusted diffusers where the air volume is adjusted by rotating the diffuser face, which closes a damper inside the diffuser, or they can be more complex with actuators and control systems to allow for control of the diffusers by a thermostat or a BMS. Let's move this over again. Areas of varying load, like perimeters or conference rooms, are handled a little differently. These areas often have other equipment like fan boxes that help them handle the higher loads. In a UFAD system, you want to put your return as high up as possible because warm air rises. And since the top of the room is not cooled, the return air will be warmer than in an overhead system. UFAD systems are very flexible. If the office moves, you just move the floor tile with the diffuser in it to its new location. Thermal comfort is another benefit of using a UFAD system. You are supplying the comfort air directly into the occupied space. The individually adjustable underfloor diffusers also allow occupants to control the airflow in their space if they have manually controlled ones. And studies have shown that when people have control of their environment, they are more productive as well. Move this up, make a little more room. UFAD systems have been found to have better indoor air quality. The concentration of air particulates in the occupied zone is lower with air distribution outlets located in the floor versus in the ceiling. Plus, you're bringing the ventilation air directly where the occupants are instead of mixing it throughout the whole space. Because of this, ASHRAE 62.1, the standard for ventilation and acceptable indoor air quality, gives underfloor systems a ventilation effectiveness factor of 1.2, which means that you can bring in less ventilation air to meet the ventilation requirements. So let's bring all this back on screen now. That's the basics of underfloor air distribution. If you have any questions or topics you'd like me to cover, leave a comment below. Don't forget to like and subscribe to our YouTube channel. Thanks for watching, and I'll see you next week.